So we've done a lot of work with graphing sine and cosine, and the note sheet has basically the beginnings of sine and cosine, where you've got just an amplitude change. Then we've talked about some phase shifts, some vertical shifts, and yes, I'm scrolling through all of this. You can see that there's notes here. This is the key that you will see. Now we're going to start doing some combination problems. Just keep going, and then these last four problems are the ones I want to do. And the reason I want to do these is because they literally encompass every possible change that we can make to these. So we're going to change the amplitude. We're going to change the period. We're going to do a phase shift. We're going to do a horizontal, a vertical shift, and we're going to figure it all out. Now, one semi-nice thing about the graphs that I've given you, and I'm saying semi-nice, is the graphs are labeled. You may need to be careful with the labels, just in terms of making sure that it matches what you're actually using, as opposed to making, just doing the next unit over. Okay, so enough of me kind of chit-chatting here. Let's actually get in here. Now, the directions way up at the top said that you were supposed to graph each trig function. That's kind of self-explanatory. However, it also said to identify the amplitude, the period, the phase shift, and the vertical shift for each graph. Remember as well, it's always beneficial to, if you have a reflection, mention that as well. That just kind of helps me maybe. All right, so problem number 13, I'm going to zoom in mostly so I can just focus on this one. Amplitude. So amplitude here is going to be based off of that coefficient, so it's a 4. The period is going to be based off of, now I'm going to do one quick thing first here. I'm going to add a 1 in front of that theta. And my period is going to be based off of this coefficient to theta. And I'm going to take the original sine period of 2 pi and divide by that coefficient of 1/4. When you take 2 divided by 1/4, you get 8 pi. Now, if you take a look at the x-axis here, it kind of makes sense that we weren't going to have a graph that only fit down here, although there are some other graphs that are really compacted based off of the graph that we're given. It's okay. So period is 8 pi here. Let's see. We also need a phase shift. Now, I want you to be very careful because the phase shift isn't just this piece. The phase shift is based off of this whole argument, okay? And this is what makes these problems extra special. I think that's the best way to phrase it. Yeah, extra special. Let's go with that. Because we have a period change, the period change affects our phase shift. So one of the ways to do this, and I'm really going to zoom in here just so I can write relatively nicely. I'm going to take this argument, the whole thing. So theta over 4 minus 7 pi over 4, and I'm going to set it equal to 0. If I can solve for theta, that will tell me where my phase shift is. So one of the things you could do very quickly is multiply this whole thing times 4, get rid of the denominators. So theta minus 7 pi is equal to 0, which means theta is equal to 7 pi. So what this tells me is where I would normally start at 0 for sine, right on the x-axis I would start at 0, I'm actually going to start at 7 pi. So positive 7 pi means I'm going to be moving to the right, that's the positive part of this, 7 pi units. And I'll figure out how many units that actually is in a minute or two. Last piece here is my vertical shift, and that one's straightforward, right? That one's nice, hasn't changed. So this is going to be up 2 units. Okay. Now I want to graph this thing, okay? And first thing I'm going to do is I'm actually going to mark out the x-axis. So I'm going to go over to 8 pi. I'm going to chop that in half. There's 4 pi. Chop that in half, 2 pi, triple it. There's my 6 pi. The reason I do that is to mark the critical points. And if you want to, you can also mark 0. That way you see all 5 of your critical points to start with. Now, when I'm going to start here, I am only going to graph little X marks the spot with the amplitude and the period, and knowing that I'm dealing with a sine graph. So sine starts, and I'll use, I don't know, purple, I guess. Sine starts on the midline or at 0. I'm going to go over to my next critical value, which would be 2 pi. I'm going to go up to the amplitude of 4. I'm going to come down to my next critical value back to the midline. 6 pi is going to be down at -4, and then 8 pi is back to the midline. So if I connected those 5 x's, that would be a 4 sine theta over 4. That would only deal with the phase shift, period, and the amplitude. I'm going to get this right eventually. All right, now I want to deal with my phase shift and vertical shift. Now, if you can keep track of it and do it both at the same time, awesome. I'm actually going to show you in this one to break it up in 2 pieces. So first thing I want to know is write 7 pi. Well, 7 pi here is 1, 2, 3, 4, 5, 6. Well, it's 7 spaces to the right. So 7 spaces. So what I want to do with the phase shift is I'm going to take all of these x's, or as many of them as I can, because I'm probably going to run out of space, and move them 7 spaces to the right. So this first x is going to move over here to 7. And now I'm just going to do a little hash or a slash mark. Let's see, the next one, 1, 2, 3, 4, 5, 6, 7. I'm probably going to start running out of space here, right here. Because if I try to go any further to the right, I don't have any room. So one of the things that you might notice is this curve, remember, it would go from starting at the origin, increasing, then decreasing. Well, if we reverse the process, so it's starting here, increase, decrease. So this would be a downslope. So basically, if we do this and go over here, I can basically work backwards to find this point right here. Now, how did I find this one? Well, I followed the amplitude, and every one of these critical values was 2 spaces apart. So I just went 2 spaces over and 4 spaces down. So 2 spaces over and then 4 spaces up. 2 spaces over, 4 spaces up. Okay, good enough. I'll figure out the graph that way. Last piece here, because I didn't do it the first time, I need to deal with my vertical shift. So every one of those little green lines that I just put in place, I'm going to move up 2 units. And then I will be able to graph this mess. Up 2, up 2. And again, if you can do the phase shift and the vertical shift all in one go, go for it. I am not going to stop you. So there's my curve. And remember that these curves keep going. So if you want to, fill the whole graph up, it's fine. Over to the left here, this would keep dropping. And then over here, this would actually keep going somewhat like that. All right, so there's problem number 13, which honestly is one of the more difficult ones. I think I kind of started with a bang here. Let's go ahead and slide over to number 14 and see if that one is any better or worse. All right, so problem number 14, remembering that I need to figure out my amplitude, my period, phase shift, and vertical shift. Now, writing those in, just, put them down in any order that you think of them. So amplitude is going to deal with that 4. So let's go ahead and mark that as a 4. Period, we're going to deal with that 3 in front of the theta. So we're going to take 2 pi, divide by that coefficient of 3. That's not going to divide nicely. So we're just going to leave it as 2 pi over 3. Which is going to get a little bit messy because these denominators are in fourths or halves, and we need a third. So we'll talk about, hopefully your fraction skills aren't too bad. Let's go ahead and grab the phase shift. Remember, that's the whole argument that we need to deal with. So I'm going to take the whole thing. So 3 theta minus 3 pi over 4 equals 0. I'm going to go ahead and multiply it by 4. So 12 theta equals, whoops, let's actually get everything in the right order. So minus 3 pi equals 0. So 12 theta equals 3 pi. Divide both sides by 12. Because remember, we're trying to get theta by itself and simplify. So theta equals pi over 4. So that is a positive value, so that's going to tell me to go to the right pi over 4 units. Okay. The straightforward one, which I always leave till last just because it makes me feel good that I know that one, is the vertical shift. That's up 1. That's it. That's just done. All right, let's see if I can make this mess work. Now, I want to mark out the period here. Now, 2 pi over 3 is not quite 3/4. So I'm going to mark that, and I'm going to go ahead and mark it as 2 pi over 3. Half of this whole distance is going to be, I don't know, right around here. That's going to be pi over 3. Half of this is around here. That's pi over 6. And if I triple pi over 6, I actually get pi over 2. So that's the one kind of nice value in that whole mess. All right, so I've labeled the x-axis. Let's go ahead and graph the initial sine curve with the amplitude and period change. So sine starts at 0. Now keep in mind that I'm only going into this mark right here of pi over 6, not the line on the grid. So be careful that you don't go too far. So pi over 6, I'm going to go up to 4. Then down to the midline, next critical value, which actually is the grid, right? It's the pi over 2 mark here, down to -4, and then to 2 pi over 3. So I've got all my critical values marked. Let's shift them right pi over 4 and up 1. Now, pi over 4 on this graph is just one space, which is the one nice part about this. It's one space to the right. So this one I'm actually going to do at once because one space and one space I can keep track of. So I'm going to take each one of these little x's and move them one space up, one space over. Keep in mind that these, the ones that aren't exactly on grid lines are going to have to move between the grid lines. Okay, so one space up, one space right. So one space, 1 and 1, 1 and 1, 1 and 1. All right. Not perfect, close enough for what we're working on. I'm okay with this. All right, I'm going to go ahead and close this video. I know I only did 2 problems, but I also know these can be quite a lot to take in. So if you have any questions or concerns, let me know. I'll go ahead and pop up a second video for question 15 and 16. And then the rest of the problems on here will be as part of the key, but I won't make a video unless somebody has a specific question.